Okay, so let's do another example of the generalized power rule. So let's assume we have f of x equals x to the 2/3 plus 1 to the 1/2 minus x squared plus 2 cubed. Okay, so now we have two terms, okay, but we can apply the generalized power rule twice, just like we did with the rule of sums and differences. It's just additively separable derivatives. That said, we can't obviously mark one g and the other g of x, so we're going to mark one g of x and another h of x. So let's say g of x equals the first one, which is x to the 2/3 plus 1, which means that g prime of x is going to equal 2/3 x to the 2/3 minus 1, which would be negative 1/3. And let's let h of x equal x squared plus 2, and therefore h prime of x is going to equal 2x. So now let's go ahead and run out the generalized power rule twice. So what this is going to look like then is f prime of x equals where's my whiteout? There it is. Okay, there it is. Okay, f prime of x, since we're using g of x here, f prime of x is going to be n g of x to the n minus 1 times g prime of x minus, and we're using h here, so it would be minus, and we'll call this exponent, we'll call that k. So we'll say k times h of x to the k minus 1 times h prime of x. Okay, so this is what the rule would look like. Okay, doing the generalized power rule twice. Okay, so we're just going to plug everything in. What we have then is f prime of x, okay, would equal 1/2 x to the 2/3 plus 1 to the negative 1/2 times 2/3 x to the negative 1/3. Okay, minus, because that's a minus sign, minus 3 times x squared plus 2 squared, okay, times 2x. Okay, now we have to combine and simplify. So we are going to get, we can multiply 1/2 times 2/3 for 2/6 or 1/3. Okay, and these have negative exponents to them, so they can go in the denominator right away. So we're going to get 1/3 times x to the 2/3 plus 1 to the 1/2 times x to the 1/3. That's going to be the first term, simplify, minus, okay, that's 6x times x squared plus 2 squared. Now we could go ahead and fool that out because that's only squared, but we're not. We'll just leave it right here. But that is the derivative of that using the generalized power rule